Hello guys, and welcome to day 3 of Days of 1,000 Subs. Now today we will be talking about the hole tool, one of the most useful and efficient tools in Alibre. So let's get to it. So I'll be starting a new part here. I'll just make a rectangular block we will use to pump full of holes. So that's 100 by 50 by 20 millimeters of height. And because I want to show you something, I will also make a step cut there of 10 millimeters. Okay. So this is the body that we will be using to cut holes in. And let's start by saying that the hole tool is up here. You click on it and you get the insert hole menu. So first of all, this insert hole menu pops up, and then you have up here a new ribbon, which looks a lot like the 2D sketch ribbon, but it's not, right? It says hole tools, and you have some things available to you and some others that are not available to you, right? For example, you cannot project to sketch. So let's start by selecting a surface, right? I didn't select one before I started the hole tool, so this is now empty. So let's click here. That says phase 4, and now this top surface is selected, and the insert hole tool just got activated. So what does that mean? Well, that means that wherever I click now, I will insert a hole, right? So I click here. There's a hole. If I switch my view to 3D, you'll see that there is a hole created. Plus, there is a node placed there, which is the guide for that hole, right? Let's place another one here at the center. And I can reset my view to 2D, right? Flat on that face if I want to. You'll see now that since I added these two holes, I get the dimension tool, available to me. I have construction geometry available to me, but not regular geometry, and I have all of my constraints. Again, I have some of the tools that I have in a 2D sketch. Okay, let me show you why the hole tool is a much better way of creating, basically holes. So you see that I'm getting two options here, a diameter, right, which let's say that this is 4 millimeters, and a depth, which let's, make 10 millimeters. You'll see now that this bottom circle indicating where this hole ends just went deeper, right? And if I change this, you'll see the diameter changing in both holes. Okay, so I'm already gaining two advantages by using the hole tool. First of all, if I made a sketch with a couple of circles and extruded, I would have had to make them equal, then dimension them, right? This is all done automatically for me. All the holes that start from the same hole command are equal between them. If I want to make a hole that has a different diameter and depth, I will need to close out this command and start a new one. Okay, but that's not just it, right? The real efficiency comes when you want a hole that is not a standard cylindrical shape. So for example, let's say that I want a counterbore hole, right? I want a screw to go through there, and I want a counterbore so that the head goes all the way in. You see that, first of all, this is called, the simple cylindrical shape is called a simple hole. And then we have the counterbore, and when I switch between them, I get additional options down here. Now, what everything does is, I think, really clearly marked. So this first dimension here is, you see this little bracket, that's the depth of the larger cylinder. In this dimension, you can see the other bracket, that's the diameter of the larger cylinder. Then we have the depth of the total hole, start of the counterbore to end of the entire hole, right? And the diameter of the smaller cylinder. So we can see here in this preview, if I switch these numbers around, you will see how that works. Okay. And let's make it 15. Okay. So for now, I'm just going to click OK and, commit these two holes. Now let's do this. Let us make a section, an inspection section view along the YZ plane. Let's flip that. This is the hole that we made. Now, if I edit this feature, and let's say that I want this type of hole, which is called counter drill, right? This is the most elaborate and complex hole that you can make with the hole wizard. So when I change it, you see that immediately the shape changes, and it does so in both holes. Okay, so that's the efficiency of the hole tool. You can switch between the holes on the fly, and the shapes will follow. Again, I can insert another hole here if I want to, and so on and so forth. Now, as I'm switching between them, you see that I am getting additional dimensions here, right? And the additional dimension I'm getting is the angle of this cone here in the middle. So if I make that 72 degrees, you see that this cone just became steeper. If I make that 30 degrees, it's even steeper. If I make that 120, it's a really shallow one. Let me just say that you can see it here in the sketch if you look closely, but the angle we're inputting here is the included angle of the entire cone, not from the center line. That's why the default one was 90 degrees. And of course, we can have a countersunk hole, which is used for flathead screws, and we can have a cone, a tapered hole. Right. So let's go back to the counterbore hole. Let's say that this is the actual hole that we want. Okay. And you can see now we've got it here. Let's turn our section off. Let's go edit our holes again. So right now I'm changing this number here, and the holes update accordingly. By the way, if I give this, a height of 4, this number, the total height of the hole, is smaller than the height of the counterbore. But you can see that Alibre doesn't really have a problem with it. You're just getting the counterbore, right? This might have a parametric use for you. It might not. You just need to be careful that if you set a total height that's less than the counterbore height, you won't get any of the smaller cylinder. So there are a couple more options in the hole tool, apart from what we just saw. And these are the depth conditions. So right now the depth condition is blind, so that's why I'm getting a number here. But I can switch that between these three options. First one is blind. I input the depth. Second is to limit geometry. So I'm selecting a geometry, and that's where my hole will end. And you see now that the total depth is grayed out because it's not driving the hole anymore. It's waiting for me to give it a limit geometry. So let's give it a limit geometry of this step. So right now I gave it the depth of this face. So you can clearly see that my holes end at exactly that depth. Okay. And as with limiting geometry with an extrusion, like extruding to geometry, you also get an offset. So I can add an offset of, let's say 2 millimeters, right? It's going 2 millimeters further down, or I can do a -2, and that's 2 millimeters above that surface, right? Or I can just leave it at 0. That's that. So I'm now driving the depth of this hole by that geometry. And just to give you an example of that, if I go into my equations and find extrusion 2, right? If I change this to -15 and hit OK, you see that my hole just became deeper. And if I change this to minus, I don't know, like 9, my hole just became short. So this hole is now driven by that other surface. So that's how you can set the geometry of the hole you're creating. And again, all of the holes that are created by the same hole command will have the same shape, and they will update automatically when that feature is changed or updated. So that's really cool. And let's start getting into the really cool stuff of the hole tool. So first of all, this is a counterbore hole. Let me just go back to blind, say that's I want a 12 millimeter depth. Okay, that's all well and good, but you can't really drill that. That has a flat bottom. So when you're making that in the machine shop, you need to, in order to get that exact shape, you need to drill it with an end mill, right? Basically. So if you actually drill it with a drill, you'll get a cone down here. But look, we get a checkbox up here that says drill. So when I click it, first of all, an additional box appears down here. I get the cone of the drill, and the default value here is 118 degrees. That's the cone of the jobber drill, right? Of the common general use drill. Let's say, and of course you can see it in the diagram here. And let's just say that I have a carbide drill that has a 135 degree cone. Input that, and that updated. Now, really important here, this 12 value is from the top of the hole to the start of that cone shape, okay, as it is shown here in the diagram. Now, if you want a value that goes directly to the bottom of the cone, you need to do a bit of math, right? And I will tell you exactly what the equation is. So in order to write this equation, what do we need to know here? Well, we need to say that this, let's say that we want the tip of that cone to be at 12 millimeters. Well, this needs to be something less, right? But how much? Well, the height of this cone is something that we can calculate. We know that the included angle of the cone is 135 degrees. That means that if we divide up this cone, right, into two smaller right angle triangles, let me just draw it in MS Paint. I just love MS Paint for this this sort of simple explanations. So let's draw it here, right? So let's say that this is our cone, right? Now, if I draw a line here in the middle, I just divided this up into two right angle triangles. And we know that this angle is 135 degrees, which means that half of it is 67.5 degrees, right? And we also know that this top line is 6 millimeters because that's the diameter of the drilled hole. So half of it must be 3. So this is 3 millimeters. So look, we have a right angle triangle. We know this, and we know this angle, and we know this sine. So basically, we can find this depth here. So how do we do that? Well, I'm going to use the tangent of this angle. So the tangent of this angle is 3 divided by this length. So this length is actually 3 divided by the tangent of this angle here. So let's go back into Alibre, right? And look, this is our angle, okay? So it is A60, and this is our diameter, that's D9. So let's go into the equation editor, and let's say that this is 12 minus half of D9 divided by the tangent of half of that included angle, which was A60. And if I click somewhere else, Alibre does the calculation and tells me that this should now be, 10.7573 and whatever, right? And now I know that this tip is exactly at 12 millimeters. And just to show you that this is actually correct, if I change this number, this first number, to 20 millimeters, which is the height of the entire block, look what happens. The tip goes right at the very bottom there. So this is how you do it. You check which parameter holds the diameter, which parameter holds the included angle of that bottom cone, and then you just say whatever depth you want minus half of the diameter divided by the tangent of half of this included angle. Okay, so we talked about these top shapes here, and we said what this drilled value does, right? We also have another checkbox here, which is reverse, and that's pretty easy to understand what it does. It reverses the direction of the hole. Okay, that's pretty standard. And now let's get to the really good stuff, right? Let's say that you need this hole to be threaded, right? Let's say that we have a countersunk hole here, and we want to screw an M6 there, right? So we want this diameter to be 5 millimeters. We want a cone up there that's 6.125 at 120 degrees, right? So that's a small chamfer to guide the screw in and to fade the thread nicely. We have our depth, like so. But how do we tell it that this is a threaded hole, right? So that we can get a call out in the 2D drawing and send downstairs to production, and they can make that hole correctly. Well, see here where it's got an option. It says thread series. Right now it's set to none, but look, we have all of these standards available, including MPT, right? So pipe threads taper. I'm just going to give you an example of the M6x1, which is what I've got here going. So let's go to ISO course. Let's tell it that we want a size 6. And it's telling me that, well, the only one I have is the standard M6. So I get to select this. It says source here. Well, that is the diameter of that threaded hole that I'm going to see in the 3D model. I can do the minor diameter, the pitch diameter, which is slightly larger, or the major diameter, or what I usually like to do, the top drill diameter, because this is what will help me do the CAM study of this part correctly. And you see now that this has got an invalid syntax because it's not recognizing the diameter anymore, right? This D9 here, it's not recognized anymore because now the diameter is driven by the pre-selected tables of the hole tool. So this is not valid anymore. Let's just say 15 millimeters. Okay, so now I'm going to get a threaded hole, right? And actually, let's make it a through hole. Makes more sense. Let's say that I don't want the thread to go all the way, right? I don't want a hole that's threaded all the way through. So how do I do that? Well, I've got another option here. It says length, hole depth, or custom, or one of these values, right? Let's go for custom. Now what happened here is the length value here drives how deep the thread goes, right? So if I say here 10 millimeters, this is a hole that for the first 10 millimeters is going to be threaded, and then it's just a through hole going the other way, right? One reason you might do it like that is for the tapping to be easier, because you can take the swerve and push it downwards. So that's how you get a hole to be threaded, halfway through. Okay, so now let's delete that hole. Let's go back to our original shape, and I'll show you another nice little trick, right? So I'll select the top surface, hit H to start the hole tool, and now the start surface is pre-selected, and it remembers that I wanted a threaded hole. Let's go back to none, so I don't want a threaded hole. Let's say that I know the exact coordinates of my hole. So one way to do it, let's say that I want this hole to be 20 millimeters in the x-axis and 10 millimeters up in the y. So one way to do it is just drop the hole and then dimension it, right? So 20 and 10. Okay, let's now say that I want a hole the other way, right? But there's another way to do it. Look, check out this button. It says direct coordinate entry. So if I click that, I can choose between absolute and relative values, right? And when I choose relative, it's telling me relative to which point that is, and it's basically relative to the last point I click, right? But let's go for absolute, and let's say that I want this to be 20 and minus 10. Hit apply and check this out. I got another hole which I drove with this entry format. And now my relative is based on that last value. So if I make this a 0 and make this a 5 and hit apply, I get another one that's 5 millimeters over. If I keep clicking on it, right, I'm just making holes that are 5 millimeters apart. However, you should know, let's click select, which will deactivate the insert hole. You should know that these are not strictly defined, right? These are floating. You need to constrain them as we do with any sketch in order to for them to be strictly defined, fully defined. Okay, but that is something that you can do if you wish and if you need to. And another thing, this also does polar coordinates, right? So if we go to absolute, we can tell it that we want that a radius of 25 and at an angle of 12.5 degrees. Hit apply. There's our hole. If we go now relative, polar relative, and just say like 10 millimeters, hit apply. Look what it's done, right? It's making a line of 12.5 degrees, and it's just adding holes on that line. So that's really useful when you know the exact coordinates of the holes that you want to be inputting. And now for the pièce de résistance of the hole tool. Let's start the hole tool again. You'll see that it says up here presets. Okay, so I'll just drop a hole in the center there. I'm just gonna click OK. So I define that hole. Let's look at it, and then I'm gonna edit it. Okay, let's look at it in 3D. I open the presets, and I have a few things stored there. So let's go for M4 countersink clearance, right? I can change the depth. So this is the standard M4 countersink hole for an M4 screw. Let's say that I want an M6 counterbore clearance that goes through. There you go. That's the correct shape for it, right? As per the ISO standard. So how do you do that? How do you get these presets going? You make a hole, you select whatever you want to select. Let's make this 6, 11, 11, 20 millimeters, and 7. Okay, so this is, let's say that I want to be making these holes regularly and across many different parts. So how do I start it? Well, I click here in the presets, I give it a name. Let's give it a name, and then you hit create. And as soon as you hit OK, that is now stored. So I can start another hole command, click here, and there's my hole, right? I can change it and I can reselect it, and there's my hole with all of the options that I selected for it. And that's super powerful, man. That's super powerful because I've got all of the holes with all of the clearances that I want to be using. I even have a few holes used in the Too Tall Toby tournaments so that I can input them very quickly. And these things store everything from depth to diameter to whatever you need. So that's it, guys. That's all you need to know about the hole tool. It's super, super powerful. You can do a whole lot with it. And generally speaking, if you want to have a hole in a part, that's how you do it. You don't revolve cut, you don't extrude cut, you use the insert hole command. Much more efficient, and you can get the actual call out for the hole in the 2D drawing ready-made for you. Super powerful. Thanks for watching, and I'll see you in the next one.